self-induction of a coil is the phenomena of induction of an EMF in a coil due to change in current in the same coil. Self-inductance is the ratio of magnetic flux to current. Self-inductance L is given by mu naught mu r n square A into L, where n is the number of turns per unit length, mu r is the relative permeability of the medium inside the coil, A is the area of the coil, and L is the length of the coil. Let's solve some problems on self-induction. The coefficient of self-inductance of a coil is L. When the number of turns of the coil is halved and the length is doubled, the self-inductance will become L, L by 2, L by 8 and L by 4. Self-inductance of a coil L is given by mu naught mu r n square A into L, where mu naught is the permeability of free space 4 pi into 10 power minus 7 Henry per meter, mu r is the relative permeability of the medium inside the coil, n is the number of turns per unit length of the coil, A is the area of the coil, L is the length of the coil. But in this problem, number of turns is given, number of turns per unit length is not given. Therefore, I will change this to some other form. N is number of turns per unit length whole square into A into L. N is N by L whole square into A. This is equal to mu naught mu r N square by L square into L, that's L, A, that's all. This implies L is proportional to, we are not changing mu r here, mu naught cannot be changed, mu r we are changing now, we are not changing A, therefore L is proportional to N square by L. Now what you are doing is, number of turns, we are changing the number of turns, we are changing the number of turns to half, number of turns is halved and the length is doubled, L is changed to 2L. What is the new old self-inductance divided by new self-inductance is equal to old N square by L divided by new N square by L. New N is N by 2 whole square divided by L by 2 is 2L. This is equal to N square by L into 2L divided by N square into 4. This 2 square is 4. That gives me N square get cancelled, L get cancelled, I get 8. L by L dash is 8. Therefore, L dash new self-inductance is equal to old self-inductance divided by 8. The answer is C, L by 8. If you have a self-induction coil and if you change the current through it, there is an EMF induced in the coil, that's called back EMF. Back EMF is given by minus L di by dt, where L is the self-inductance, I is the current, di by dt is the rate of change of current. Let's solve one problem on back EMF. In a given branch AB of a circuit, a current I is equal to 10t plus 5 amp is flowing, t is in seconds. At time t equals 0, the potential difference between A and B, VA minus VB is, the circuit is here. Option A 15 volt, option B minus 15 volt, option C 5 volt and the option D is minus 5 volt. As you can see here, the current is coming from right to left. Therefore, this should be at a higher potential, this should be at a lower potential. This can, I will redraw this circuit, and the current is given by I is equal to 10t plus 5. Therefore, the current is increasing with time. If the current increases with time, then this self-inductance coil will oppose the current coming towards it. Therefore, this would become plus and this would become minus. This is equivalent to a cell of EMF, E is equal to L di by dt, rate of change of current into self-inductance. It is equivalent to a battery. This at a higher potential, this at a lower potential. The next thing is, I have to calculate VA minus VB at t equals 0. The current in the circuit at t equals 0 is t 10 into 0 plus 5, that is 5 amp. Therefore, the current is 5 amp. I will redraw the circuit again. This is the 10 volt battery here, and this is the self-inductance. The self-inductance can be written as a cell now. This is cell. This has 10 volt of voltage, and this is the resistance. The current is coming like this. The current is 5 amp. this is 3 ohm. What's the EMF? EMF E is equal to L is 1 into di by dt, rate of change of this one, d by dt of 10t plus phi, d by dt of phi is 0, d by dt of 10t is 10, therefore this is 10, this is equal to 10 volt, therefore this is equivalent to a battery of 10 volt, this is point B, this is point A. B is lower potential, A is at a higher potential. Now you have this circuit, you have to find VB minus VA. Let's apply Kirchhoff voltage law starting from some point. I choose this point. Let's go like this and let's come back. If I go like this, I step from higher potential lower potential, therefore that's minus 10, this is minus 10. As I go here, I step up, therefore that should be plus 10, the voltage is plus 10. The current is coming towards me, therefore the current is positive, 5 into 3 is 15, plus 15. Next I come here, that is potential A, potential of B is lower, therefore I step from higher potential to lower potential, therefore this will be minus VA minus VB. I come here, no problem, that is 0. The algebraic sum of changes in potential or a closed loop is 0. These two are cancelled. This is minus VA minus VB, carried to the other side become plus VA minus VB. Therefore, VA minus VB is equal to 15 volt. The answer is VA minus VB is equal to 15 volt. The answer is A. In a self-inductance, if I current is flowing through the self-inductance, then there is magnetic energy stored in the coil. There is a magnetic energy stored in the coil. The magnetic energy E is given by half Li square. It is hard to set up a current in the coil. For that, the battery spends some energy. That energy is stored in the form of magnetic energy. Let's solve one problem on magnetic energy stored in the coil. In the given circuit, the magnetic energy stored in the coil L is 25 joule. The value of coefficient of self-inductance is, that is, A 4 Henry, B 1 Henry, C 2 Henry and D 8 Henry. It is given that the circuit consists of a L and R connected in series. There is a 10 volt DC supply here. The energy stored in L is 25 joules. You have to find what the value of L is. For DC, a pure inductor does not offer any resistance. Therefore, the only resistance in the circuit is 2 ohm. Therefore, current in the circuit must be voltage divided by resistance, that is equal to voltage is 10 divided by resistance is 2, that is equal to 5 amp. The current in the circuit is 5 amp. The energy stored in the coil E is given by half Li square, which implies E is given, that is 25, is equal to half into L value is unknown, I substitute as it is, into I square is, I is 5 square. This 5 square is 25, there is a 25 here, I can cancel these two 25s. Therefore, I get L by 2 equals 1, that implies L is equal to 2 Henry. The answer is option C, 2 Henry. Let's move on to the next topic, which is mutual induction. Mutual induction is the phenomena of induction of an EMF in a coil due to change in current in a nearby coil. Amount of induced EMF in the secondary coil is equal to M into rate of change of current through the first coil, where M is called the coefficient of mutual induction. Let's solve one problem on mutual induction. A current of I is equal to 10 cos 100 pi t amp passed in the first coil induces a peak EMF of 5 pi volt in the second coil. The mutual inductance for the pair of coils is 5 millihenry, 10 millihenry, 15 millihenry, 20 millihenry. Now you are given with the expression for current. The current in the first coil, I call that I1 current in the first coil is equal to 10 cos 100 pi t amps. Induces an EMF of EMF across the secondary of 5 pi volt. But this is not the induced EMF instantaneous, but it is the peak EMF. Therefore, I write E2 naught here. That's 5 pi volt. By principle of mutual induction, E2 EMF across the secondary coil is equal to minus M. M is the coefficient of mutual inductance into rate of change of current through the first coil, which is equal to minus M into di by dt. That's d by dt of 10 cos 100 pi t, which is equal to minus M into 10 can be kept outside. D by dt of cos 100 pi t is 100 pi minus sin 100 pi t. But minus, this becomes plus. Therefore, I get 100 into 10 is 1000 pi m into sin 100 pi t. This is the instantaneous EMF across the secondary. What's the peak EMF across the secondary? Peak EMF across the secondary is this one. But it is given that peak EMF across the secondary is 5 pi volt. Therefore, 5 pi volt is equal to, from this one 5 pi volt must be 1000 pi into coefficient of mutual inductance M. Pi gets cancelled. 1000 is 10 power 3. This implies M is equal to 5 divided by 10 power 3, which is equal to 5 into 10 power minus 3, which is equal to 5 milli. 10 power minus 3 is milli. SI unit of mutual inductance is Henry. Therefore, the answer is 5 millihenry. The answer is A. Go on to the next concept, which is AC generator. AC generator was devised by Nikola Tesla. In an AC generator, a coil rotates in a magnetic field and there is an EMF induced. That is a conversion of mechanical energy into electrical energy. It works on the principle of electromagnetic induction. The EMF induced in an AC generator is given by E is equal to E naught sin 2 pi nu t or omega t. Nu is the frequency of rotation, t is the time. E naught is called the peak voltage and E is called the instantaneous voltage. Peak voltage E naught is given by NBA omega, where N is the number of turns, B is the magnetic field, A is the area and omega is the angular frequency of rotation. NBA omega is the peak voltage across the AC generator. Let us solve some questions on AC generator. In a region of uniform magnetic field of 0.01 Tesla, a circular coil of diameter 60 centimeter and resistance pi square ohm is rotated about a diametrical axis perpendicular to the magnetic field. If the coil rotates at 200 rpm, the maximum induced current is. Magnetic field is given, which is 0.01 Tesla. It is a circular coil. Radius is given 30 centimeter. Diameter is 60, therefore radius must be 30 centimeter. The resistance of the coil is given. The angular frequency is given, angular velocity is given, that is 200 rpm. You have to find the induced current. What is the induced current in the circuit? Maximum induced current. Maximum induced current is equal to maximum EMF across the coil divided by the resistance of the coil. But maximum EMF in an AC generator is given by NBA omega divided by R, which is equal to N into B into, it's a circular coil, you can see here. Therefore, the area must be pi R square into omega divided by resistance R. Let us calculate what the value of omega is first. Omega is 200 rpm, which is equal to 200. 1 revolution means 2 pi radians, therefore 200 into 2 pi divided by per minute means 60 seconds. This can be cancelled by 30. This goes one time, that is 20 pi by 3 radian per second. Next, let us calculate I naught. I naught is equal to N. It is a coil, therefore N equals 1 into B. B is 0.01 Tesla, I write it 10 power minus 2. 0.01 is 10 power minus 2 into A is pi into r square. R square is 0.3 meters, that is 60 centimeters is the diameter, therefore radius is 30 centimeter, which is 3 into 10 power minus 1. 3 into 10 power minus 1 whole square is 9 into 10 power minus 2 into pi r square is over, n is over, b is over. Next omega. Omega is 20 pi divided by 3 into, here is resistance R, resistance is pi square ohm. This pi into pi is pi square gets cancelled. I get 3 goes 3 times, 3 into 20 is 60, that's 60 into 10 power minus 4, which is equal to 6 into 10 power minus 3 amp, which is equal to 6 milliamp. The answer is C, 6 milliamp. Let's solve one more problem on AC generator. An AC generator produces an EMF of E is equal to 311 sin 314t. The coil has a resistance of 10 ohm. If the generator is connected to an external resistance of 100 ohm, the power across the external circuit is 484 watt, 400 watt, 440 watt, 369 watt. The EMF produced by the generator is given, that's 311 sin 314t. The AC generator itself has some resistance, that's 10 ohm, that's equivalent to internal resistance. Generator is connected to an external resistance of 100 ohm, that's external resistance. I have to calculate the power across the external circuit. Power in the external circuit is equal to IRMS current whole square into external resistance. But you are given with E naught, that is 311. How do you find IR? I is equal to E by R plus R, that is IRMS is equal to ERMS divided by external resistance plus internal resistance. Therefore, power becomes ER divided by R plus R whole square into R. But the problem here is that you know peak voltage, that's 311 volt, you don't know what the RMS voltage is. As E naught is 311, ERMS is 311 divided by root 2, which is, as you know, that's 220. 220 volt RMS corresponds to peak voltage of 311 volts. That gives me 220 divided by R. R is external resistance 100 ohm plus small r. Small r is the coil resistance, generator resistance, that's 10 ohm, int whole square into external resistance, that's 100. This 100 into 10, 100 plus 10, 110. 220 divided by 110 is 2. 2 square is 4. 4 into 100 is 400 watt. The answer is B, 400 watt. ಇಷ್ಟೊತ್ತಿನವರೆಗೆ ನಾವು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅನ್ನೋ ಚಾಪ್ಟರ್ನಲ್ಲಿ ಬರುವಂಥ ಎಲ್ಲ ವಿಷಯಗಳ ಮೇಲೂ ಪ್ರಾಬ್ಲಮ್ಗಳನ್ನು ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀವಿ. ಈ ಎಲ್ಲ ಫಾರ್ಮುಲಾಗಳನ್ನು ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ, ಪ್ರಾಬ್ಲಮ್ಗಳನ್ನು ಆದಷ್ಟು ಜಾಸ್ತಿ ಸಾಲ್ವ್ ಮಾಡಿ. ನಿಮ್ಮ CET ಎಕ್ಸಾಮು ಚೆನ್ನಾಗಲಿ, ಒಳ್ಳೆ ಮಾರ್ಕ್ಸ್ ಬರಲಿ, ನಿಮ್ಮ ಭವಿಷ್ಯ ಚೆನ್ನಾಗಿರಲಿ. ಎಲ್ಲರಿಗೂ ವಂದನೆಗಳು.